Hey everyone, and welcome to The Explainer. Today we're jumping right into annuities. This is an absolutely crucial concept in finance, and for sure something you've got to know for the CFA exam. We're going to break down what they are, how to solve for them, and really see why they're the foundation for so many financial calculations. Let's get right to it.
All right, here's our roadmap. We're going to start with the absolute basics. What even is an annuity? Then we'll get practical and look at your calculator, which is basically a superpower for these problems. After that, we'll unpack the huge difference between ordinary and annuity due, and then the fun part. We'll apply it all to some real-world examples. Stick with me, and by the end of this, you'll be set.
So, first things first, what are we actually talking about when we say annuity? It's not some complicated product. Really, it's just a pattern, a nice, steady, predictable series of cash flows. Think of it like a financial rhythm.
But, and this is a big but, for any stream of payments to officially get the title annuity, it has to play by a very specific set of rules. 3 of them to be exact, and they are not negotiable.
And here they are. Rule 1. The time between each payment has to be exactly the same. Rule 2. Every single payment has to be for the exact same amount of money. And Rule 3. The cash all has to be going the same way, either all coming in or all going out. You know, like saving exactly $100 on the last day of every year for 3 years straight. That's a textbook annuity.
Okay, so the theory is one thing, but how do we actually solve these problems without a massive headache? Well, the answer is right there in your hand. Let's look at those 5 time value of money keys in your financial calculator, because they're going to do all the heavy lifting for us.
First up is N. Now, this is a super common trip-up point, so listen close. N is the total number of periods, not necessarily the number of years. So if you've got a 3-year loan with semi-annual payments, your N isn't 3, it's 6. That's 3 years times 2 payments per year. Next is I/Y, the interest rate per period. And just like N, it has to be on the same page. If the annual rate is 10%, but you're compounding semi-annually, what's your I/Y? You got it, it's 5. 10% divided by 2. And a pro tip, you almost always enter this as a whole number, so just punch in 5, not 0.05. PV stands for present value. This basically tells you what that whole future stream of payments is worth in today's money, right at the very beginning, at time 0. It's like asking, what lump sum would I need right now to create that same series of future payments?
Then there's PMT, which is short for payment. This is the star of the show. It's that constant reoccurring cash flow amount that makes an annuity in the first place.
And last but not least, FV is our future value. This is the grand total at the finish line. It's what all your payments plus all the interest they've been earning along the way will add up to at the very end. It's the big pile of cash you have when it's all over.
Okay, so we know our tools now, but we've got to talk about something that changes everything in your calculations: timing. See, not all annuities are the same. The main difference between an ordinary annuity and an annuity due, it all comes down to when the payments happen.
So this right here is an ordinary annuity. The key thing to notice is that the payments happen at the end of each period. You see that? The first payment isn't right away at time 0, it's 1 period later at time 1.
And an annuity due, well, it's the exact opposite. The payments happen at the beginning of each period. This means you get that first payment right out of the gate, immediately at time 0.
And this timing difference, it makes a huge difference to your wallet. Think of it like getting a head start in a race. With an annuity due, every single payment is made earlier, which means each one has an extra period to sit there and earn interest. That's why an annuity due will always have a higher future value and present value than the same exact ordinary annuity.
Okay, if you're studying for an exam, listen up, because this is critical. Your calculator's default setting is for an ordinary annuity, what we call end mode. If you're working with an annuity due, you have to manually go in and switch your calculator to BGN, or beginning mode. Forget this, and you're going to get the wrong answer every time.
All right, we've got the concepts down, we've got the calculator settings straight, so let's put this into practice. Let's see how these ideas actually get used to solve real-life problems like figuring out loans or planning for retirement.
Loan amortization is a perfect example of an ordinary annuity that you probably already know. When you get a mortgage or a car loan, what are you doing? You're agreeing to make a series of equal payments over time to pay it all back. That's an annuity.
This is an amortization schedule, and it shows you exactly where your money is going with each payment. What's so interesting is that at the beginning of the loan, a huge chunk of your payment is just going to interest. But as you go along and pay down that principal, more and more of your payment starts to actually attack the loan balance itself.
Okay, time to level up a bit. Let's look at a more complex problem where you're basically linking two annuities together. This is a classic exam question, but it's also how people really plan for huge life goals like retirement or sending a kid to college.
So, the secret to solving these two-stage problems is to work backward. It feels a little weird at first, but it works. First, you figure out the total lump sum you'll need right at the beginning of the spending phase. That's a present value calculation. Then, that lump sum becomes your target, your future value goal for your savings phase. Once you have that goal, it's easy to solve for how much you need to save each period to get there.
So far, we've been living in a perfect world of equal, finite payments. But what happens when things get a little weird? What if the payments go on forever? Or what if they're not equal? Let's check out a really cool special case.
This is a perpetuity. It's an annuity where the equal payments just keep coming forever. Now, you can't really calculate the future value of infinity, right? But what's amazing is that you can calculate its present value with a super simple formula. It's just the payment divided by the interest rate. That's it.
Wow, we have covered a lot of ground, from the absolute basics all the way to multi-stage problems. So, before we wrap up, let's do a quick final review of the most important things to remember. This is the stuff you really want to lock in.
If you walk away with anything from this, let it be this. Always, always check your timing and your consistency. Is it an ordinary annuity at the end of the period or an annuity due at the beginning? Is your calculator in the right mode? And are your N, IY, and PMT all speaking the same language? All monthly, all annually, whatever. If you can nail those details, you can solve pretty much any annuity problem they throw at you.
And that's our deep dive into the world of annuities. These concepts are seriously the bedrock for so many other ideas in finance. But it all leads us to a really interesting next question, doesn't it? An annuity is defined by those perfect equal payments. But in the real world, what happens when the cash flows are all over the place? We'll leave you with that thought.
我是替纽约